Good morning. Welcome to episode number 19 of the ZOOMTOWN experiment. This is the second or third in a series covering the power supply for the Zoomie. For today's video, we're going to be looking at making a PCB, which is a critical element of keeping things compact on the Zoomie. Let's take a look at what we're going to cover. We'll review the purpose and function of this circuit board. We'll show the design in a software package called Sprint Layout. I'll show some post-processing software that takes the output data from Sprint Layout and makes it suitable for use in a CNC machine. We'll machine the PCB on a CNC machine. We'll solder all components in place, set some voltages on the voltage converters, and that'll bring us to the end of this part of the whole power supply series. This is the circuit board we're going to make. Very, very simple in design. Just got a few traces on the back side, some labels on the front side, and paint. Quite simple. And quite easy to make. In truth, this could have easily been done on perf board, but I have the ability to use my CNC, so I do. And this is where to locate on the next deck going up on the Zoomie. Now, most circuit boards start with a schematic. Simple ones like this can truly be done without a schematic, but you really should have a schematic to define what you're trying to create. And in our case, this is most of what's going to be on this PCB. We'll have a few screw terminals, a couple of DC to DC converters, a resistor, and an LED. And that will populate the entire PCB. Now, the reason why I've done it this way is I can make it more compact using a PCB than discrete wiring. Plus, it gives us mounting locations to put the screw terminals and so forth. So all around it's for convenience and for compactness that I went through all the trouble of creating the PCB. After I've got a schematic designed, then my next step is to go into one of my favorite and probably longest used applications for electrical design. And it's Sprint Layout. It's, I think, out of Germany. And it's a very, very easy to use, simple to use PCB layout tool. It just works really good, especially if you're doing CNC work. There's very minimal amount of input you got to do. You don't got to create a schematic in it or any of that stuff. Just start drawing what you want. You can specify the types of pads that you want, the width of the traces, all that, and it's done quite easily. Now, for example, here, I'll just do something over in this area. Now, the halo that's following around my mouse pointer, don't confuse that with part of the Sprint Layout software. That's what I have to do for when I'm recording the desktop for you folks so you can see what it is that I'm pointing at. But down here, I'm going to select my copper layer, and we'll go with pads. It'll be a 90 thousandths diameter with a 30 thousandths hole. So I'll put one, say, there, and we'll put one there, and another one there, and finally one way over here. Now, if I want to connect that with a trace, I specify the width of the trace here. This is in mils. Basically, it's 1/1000th of an inch. And, of course, you can work with it in inch or metric. Me being here in the U.S., I always default to the inch system. But you just click there. Now, I want it to come down at a 45, so I'll go there, click there, come down at a 45, click there. And if I want to come down, maybe I got to get around something in this area. I could come down here like so, and click into that area. And then you just keep building all along the way. For lettering and labels, you switch to your copper side 1 and do that. It will do the letter engraving and all that for you on the output. For the outline, I use a trace width that'll be equal to the tool size, and then that way I get a real good visual for how it'll actually end up in the real world. Now, once you get through and you do your whole design thing, I go to Export, Isolation Milling, and I select what I want to do, copper top, copper bottom, set a few other settings here. It'll output all the drillings. And I want to drill from the bottom. Outline milling, I want to mill from the bottom. All I'll do on the top side is just simply the engraving. I set my font to single lines so it's very legible. And this is the job list that it'll create. And based on this, it'll create a number of files that I would take through some form of post-processing software. So I would click Create. I don't want to overwrite my existing files in here. This is actually my live design, so I won't mess it up. But then that would create a series of files, one for each drill, one for each tool or type of machining operation. From there, I would import it into some custom software that I wrote in Python using Pygame. I did this a number of years back to make it easy to have a program get automatically created specifically formatted for my CNC machine. As you can see here, we just load in the file. It'll show me what it looks like. I check my cutter feed rates and depths, but all the default values work really well, so I don't bother with them anymore. Just use them. And then just click the output. It goes through and it'll process the entire PCB and output the G code for me. It works really simple, and it's been used for a long time now, and I just couldn't be more happy with the program. The G code output would look very much like this one, or I should say exactly like this one. This is the G code to make this particular circuit board, but if you've ever seen G code, it's pretty universal. You got your X, Y, Z's, feed rates, offsets, etc. Really quite straightforward. From here, I would take this and put that or load that into my CNC machine. Now this video will play again in a minute here, but what I wanted to show you is the PCB material and my work surfaces that I use for PCB making on my router. This master table or subtable here is just a clamping surface. It's flat and it's true and all that, but we're going to be, as you can see here, drilling through into this thing all the time, and that's a spoil board. And that's just a waste piece of material. So I'll probably make 30-40 PCBs on it, throw it away, resurface a new one, and I'm good to go with a nice, accurately flat surface. PCB material, I get whatever I can find on eBay. Usually I can get it for about $1 or $2 for say an 8-inch by 8-inch piece. Buy in bulk, you get 10-20 pieces, and it'll last me for quite a while. I use the Scotch double-sided tape. I found that to work brilliantly good. It's a very consistent thickness. So I just put the tape on there, put that whole assembly on top of the spoil board, press it down. I usually put a weight on it for a few minutes, and it's good to go. We pick up the center location of wherever our origin is, load the program, I graph it just to feel good about it, and then I start running it. And here we'll watch some of the engraving. That tool looks like this. As you can see, it's a very fine pointed engraving tool. The small diameter end is about 80 thousandths of an inch or 1.5 millimeters, and it's got a 60-degree point on it. This is the tool change mechanism. It's all automatic. A lot of that went through a long engineering process. Took me a very long time to design and get this whole system to work and work reliably. What it will do is it'll unscrew the collet from the spindle, and just the friction keeps the tool in there. And it will then go over and put it in a magazine, which we'll see here now. magazine will close the cover and hold it in the magazine. It'll move over to the next location for the next tool and come down and pick that one up. And all the tool diameters are known to the software, so it knows exactly which tool to get based on the magazine position that's in the database. It'll measure the tool's length after it loads it, and it'll measure that easily within 1/1000th of an inch. It'll go through and it can drill pretty darn quick. That's a 20,000ths diameter drill, and it's just cruising right along. And of course, each hole location is probably accurate within 1/1000th of an inch. Now, you might be wondering why it seems kind of wobbly when the tool moves from place to place. There's a lot of mass moving side to side, and this whole machine is on wheels, so it kind of wobbles around. Now, to get the lettering, I take the opposite side of the PCB, spray paint it a dark color, and then I take the same engraving tool and I'll go through and engrave the lettering onto the surface. That way we get white letters on a dark surface. I typically use either black or dark blues, dark greens, etc. And it's very, very legible, as you had seen in the previous image. And there's the finished PCB. Now, with regard to where all this is going to end up in the Zoomie, here is our 3D model again. And the battery deck is what we made last week. We've got this mid deck here, and that'll be where all of these components will be assembled. We saw this deck as well last week. And here is the PCB with the screw terminals and the little circuit boards that are our DC to DC converters. Back over here on the bench in the real world, this is what we've got. We'll move this over here. I'll take Mr. Robot, or my little tiny robot, out of there. Get this put on there like so. This will be screwed, once it's all assembled, will be screwed and fastened to there. And then we'll add, in the next episode, we'll add in the rest of the components and get this whole power supply deck completely finished. But for today, all we're going to do is finish up this circuit board. And now we can turn our attention to the actual assembly of the PCB, populating it with all the components. I'm going to start with my headers for the little DC to DC converter power supplies. I'll start by soldering those to the header pins, which are already on the main PCB, the one that we made. Then I'll flip it over and solder in the header pins on the back side of our PCB. to get our screw terminals installed. And of course, very easy to put these in pointing the wrong way so that you end up where you can't get the wires in. Now I need a resistor in this little area here. And of course my resistor is bigger than that, but there's an easy fix for that. We'll install it vertically. Now this is how the assembly fits together. But my power LED goes through that hole. And I think that should do it. That will go in like so. That'll get screwed down like that. Gotta get that bent up just a shave. And that'll do it. All right, to perform the final testing and setting, I've got on these two leads are the voltage coming in. I've got my power supply set at 7.5 volts, which will be roughly the nominal voltage coming in off of the 18650 battery pack. And then right now, this particular side, this little power supply, needs to give me 5 volts. And that's the one that'll primarily be powering the PICO. And of course, you got to use these little cute screwdrivers and turn them very gently. Oop, too far. And any downward pressure on it will give you very different voltage settings, so requires a gentle light touch. I'm good with 5.028 volts. PICO can handle up to about 5.1. I think with that I'm good with it. Now what I'll do is I'm going to adjust my power supply voltage up and down about a volt or a volt and a half to see if it affects my voltage there outside of the DC to DC converter. All right. That's 9 volts, and I'll come down to 6 volts. And it's pretty stable. So with that, I'm pretty good. I'll do the same on the opposite side for our 3.3 volt supply. Now, in case you're wondering, once these get under load, yes, the voltages will drop, but I'll fine-tune them at that point. The important aspect of this step is to get them set close to the correct voltage to start with, so that when we don't do final assembly and turn it on, we start blowing up components. Well, that turned out pretty nice. Glad to get that all done. Good help from my little buddy Tiny Bot there. So this episode, we're wrapping up at this stage. We've got a working power supply per se, at least with our circuit board portion of it. Next week, we're going to go through and finish up all the power supply system. So we'll bring all the components together, do some wiring, and so on. After that, we're getting closer to the brain of the robot, so things are moving right along. Thanks again for watching, and I look forward to seeing you next week.